My name is John Copans. I am the director of the Montpelier Commission for Recovery and Resilience. We're an organization that really emerged from the 2023 floods here in Montpelier. We're working on a variety of projects to make our community more resilient to future floods and other events. But I'm really here today as part of a group that we have named the Winooski Flood Resilience Collaborative. And I'm going to actually list a few organizations that are part of the planning team for that effort right at the outset, because this really is a team effort. We're working together with the state of Vermont, the State of Vermont Recovery Office, Vermont DEC is part of this. Both the Chittenden and Central Vermont Regional Planning Commissions are part of this effort. Friends of the Winooski, the Cabot Flood Resiliency Task Force, the Vermont River Conservancy, Winooski Natural Resources Conservation District, and then the Vermont Council on Rural Development is also part of this planning team. The idea around the Winooski Flood Resilience Collaborative is that none of us as individual communities are going to sort of solve the challenge of addressing flooding and flood resilience. It's the obvious thing to say that it really is going to require collaboration as a watershed, working together across town lines. And essentially, the collaborative is intended to create a venue for that activity to happen. We had our first in-person gathering back on December 4th here in Montpelier, about 80 people from 25 towns across the watershed. Many of you here today were part of that conversation up at the Greenway Institute here in Montpelier. And then our next event is, as folks know, on May 14th, we're going to be at Crossett Brook Middle School for an event that is really focused on mapping and modeling. We will have a presentation, a joint presentation by Roy Schiff from SLR, who I think is on here today, and also Rebecca Deal from UVM. And then we will sort of break out into smaller groups to sort of build stronger connections and think together about how we're using mapping and modeling in our own communities, or how we need it in our own community to identify and move forward with projects. We felt like, next week is about sort of modeling of the rivers, but part of what you need to be thinking about is precipitation. What kind of storms are we experiencing, and are we likely to experience, right? Fundamentally, floods start in the atmosphere with weather patterns and with big storms. And so I had the good fortune last year at the Vermont Emergency Management Conference to sit in on a session, put a presentation by Scott Whittier, and it contrasted the 2023 and 2024 flooding events. And I found it very illuminating. And so was really excited to reach out to Scott and invite him to do something similar, but really focused on the Winooski River Basin, and to look at sort of historic events and to help us understand a little more of sort of what goes into those forecasts. How do we understand sort of those river gauge forecasts? And so really happy to welcome Scott. Scott is currently the warning coordination meteorologist at the NOAA National Weather Service Burlington, Vermont forecast office. He's been at that National Weather Service in Burlington since 1993. Scott was educated right here. He's homegrown, right? Part of the he's a graduate of the Linden State College meteorology program, and was back in 2013 was awarded the Northeast States Emergency Consortium's Emergency Manager of the Year, in part because of all of the work he did around Tropical Storm Irene, and also as part of the Vermont catastrophic full-scale exercise back in 2010. So with that, I'm going to turn it over to Scott. just in terms of how we're going to run this, Scott's got a presentation. There will be an opportunity for sort of live Q&A at the tail end of this. But also, if folks have questions in the intervening period, feel free to throw those in chat as Scott goes through his presentation. But otherwise, we'll welcome questions at the tail end of things. So with that, I'm going to turn it over to Scott. And so go for it.
Great. Thanks, John. Are you able to see the presentation?
Got it.
All righty. Great.
Yep.
Good. So good afternoon, everybody. It's great to be here. And John, again, thank you for inviting me. We've had a lot of flooding the last couple of years, and the Winooski Basin has been no exception to that. So when John came to me asking about the presentation, I thought it'd be a good opportunity to kind of review some of the history of the watershed here in Winooski, the Winooski Basin. So basically, it's just a brief overview of the basin itself, some historical flooding and precipitation patterns that we have seen over the years. That includes the recent flash flooding and river flooding, the snowmelt flooding that occurred in December of 2023. Of course, the ice jam, we can't forget that. That used to be the not flood of record, but the last flood we really remembered until Irene came about. I'm going to be talking a little bit about this precipitation average reoccurrence intervals, basically, AKA the return periods, the perceptions and misperceptions on that. And I'm probably going to have time because I want to go and kind of introduce people where to find hydrographs and how to read hydrographs. So with that, as you all know, the watershed for the Winooski Basin basically starts up in the northeast portion near the Cabot area, southeast portion near Williamstown, southwestern areas near the Warren area, and up north to Stowe, and then it all flows pretty much east to west. A good 90% of the area is forested. Another 5% probably is cultivated, some sort of farmlands or whatever, with another 3 to 5% probably developed. And of course, those developed areas are where you got the main roads. You got your Route 2 corridor and, of course, your 89 corridor. The Winooski Basin is basically made of about 8 or 9 sub-basins as well. And I think you're all pretty aware of that, so I'm not going to speak too much more to that. In terms of whatever gauges are available to take river observations or provide river forecasts, we do have several automated basins to collect data across the entire area. The 4 locations that have stars are where there's actually forecast points along the river that the Northeast River Forecast Center will make deterministic forecasts for. So that, of course, would be Montpelier, Waterbury, and Essex Junction along the Winooski itself, and then Moortown, which is one of the bigger tributaries that comes into the Winooski. So I am going to go over kind of the crest history of those 4 hydrographs, basically going from upstream at Montpelier to Moortown to Waterbury and eventually to Essex Junction. So there's a lot of data on here. I really have it in here to show recent events and how recent events have gone to more of the historical realm of cases recently, and knowing that this would be available for people to look at a little bit later. But basically, the top message to take away from is no matter where you are within the basin for gauge locations, the top 3 events are the November 27th flood. Nothing has beaten that so far. And then number 2 or number 3, based on which forecast point you are, is either going to be the recent July 2023 flooding or Irene that happened in August of 2011. But you can see from the key that I have here in the bottom center, there's recent flooding of July 2024. The orange is the snowmelt from December 23. Irene, of course, is August of 2011. The light blue is the flash flooding that we had in May of 2011 that impacted the larger river itself. The green is, which is synonymous to what we happened in July of 2023, is June of 1973. And then lastly, I have in here in magenta is the 1938 hurricane, where the winds were probably more of an impact than the flooding itself. but still it shows up on several of our records. So you look at Winooski at Montpelier, of course, it's the 27 flood, which is the standard bearer, with the recent July 2023 actually overtaking the Irene, which was August 29, 2011, by a little over 2 feet. So 23 was a little bit more of a flood in Montpelier than 2011. And you can see the May 27th, 2011 event is number 4. So we have quite a, and then number 9 was the snowmelt of 2023. Now we look downstream a little bit to Waterbury. This gauge was not really installed until 2010, 2011. So the period of record is much less, but nonetheless, Irene is the number 1. July 23 is number 2. July of last year was number 3. And then you see the snowmelt flooding of December 23 being number 4, and the flash flooding on May of 2011 being in there. We go further downstream to Moortown. Again, 27 is number 1. Irene is number 2. And it's actually the 38 hurricane, which is number 3 for Moortown. You can see that the July 2023 flooding was 49th for the height level over at Moortown, and I'll get into more of that later. The June 24 flooding, which is very similar to the July 23 flooding, was number 24. And then the May flash flood of 2011 is the 112th level for Moortown. So I'll show you where the rain falls on a certain part of the basin, how it affects the gauge heights. And then finally, at the downstream gauge where everything collects before it enters Lake Champlain, 27 flood is number 1. The recent July flooding is 23, and Irene is number 24. So we've gotten it from flash flooding, we've gotten it from snowmelt flooding, we've gotten it from a tropical situation. So that's been our crest history for the Winooski basins. And for the state of Vermont overall, our top 5, or in this case, our top 4 weather disasters for the state of Vermont have all been flooding. The 27 flood, which brought 84 fatalities and nearly 1,300 bridges lost, as well as hundreds of miles of roads and railroad tracks. Irene, which saw 5 fatalities. The Long Island / New England hurricane of September 1938, where it was devastating wind, but also some flooding. And then more recently, the summer of 2023, which is very similar to the June 1973 flooding. So those are really our top 4, top 5 weather events. Now, if you look at the top right here, part of my slide, there have been 53 presidential disasters in Vermont since 1963. 42 have been pretty much flood or wind related, so 82%. Now, the threshold to get a PDA in the state of Vermont is relatively low. It's approximately $1.60 or $1.80 per person in the state, and you have to meet a state requirement before you meet a county requirement in order to get PDA. And I'm sure some of you have heard in more the recent news and with the current administration that value could maybe multiply by 4 times. So instead of being 1.4 million for the statewide, that it could end up being closer to 6 million. That's all being proposed. Nothing has been passed by law, but I'm sure you've seen the news, and I've done some number crunching, and that's what I got if the proposal that's being proposed does occur. So just give you a kind of a little backdrop on that. So the 27 flood. No, this satellite is not from the 1927 flood, because satellites weren't good until the 1960s. But it's kind of the similar meteorological makeup. We had a tropical storm that formed near Cuba. By the time it got off the Florida coast, it was no longer a tropical storm. It was just kind of an area of low pressure. But it brought a copious amount of water, as you see on this satellite, water vapor that streams up into New England. And actually, that satellite picture is from the Halloween storm of 2019. Yeah, Halloween storm of 2019, where we saw a lot of flooding. But anyways, the background on the 27 flood, October, we saw the state of Vermont witnessed 200% of normal of their precipitation for the month of October preceding this November 3rd, November 4th flooding event. You can see the rainfall totals were largely 4 to 8 inches across the state or even higher. And also the terrain in the state of Vermont in 1927 looked a lot different than it does now. In 1927, nearly 70% of the state was defoliated and it was farmland. So if you're looking at in November in 1927 with 70% of your land being farmland, there was no crops at that time because you've already harvested your crops. Whatever trees and forests you still had left were bare because you're in November. The ground has already gone through various stages of a freezing taking place because we are in November. So when you add the antecedent conditions and no ability to hold any water because you're talking about topsoil and not much forested area, we were just seeing a massive release of water when that rain fell. And that's why the 27 flood is a new standard. In fact, somebody asked me after Hurricane Helene impacted North Carolina mountains that how would that relate to Vermont? And I said, if you look at what happened in the Carolinas and what happened here in 1927, I would say Helene was North Carolina's 1927. So that was the type of destruction that they saw down there, is the destruction we saw here in 1927. Irene, 2011, the top is the radar of how it unfolded. It was basically a 12 to 15 hour rainfall event. Again, the year of 2011 was extremely wet across the area. We saw record snowfall that winter. We had the flooding in April. We had the flash flooding in May. We had Lake Champlain that exceeded its previous record lake level by more than 3 feet. So 2011 was a very, very wet year. And about 3 to 4 days prior to Irene, there was a system that delivered 1 to 2 inches of rain across southern Vermont. So therefore, when Irene came with those rainfall totals that you can see here in the upper right, the greatest impacts were largely across the southern 4 counties of Vermont. We did see impacts across Addison, Washington, Orange, and Caledonia as well, but the greatest impacts were actually largely down in our southern 4 counties. And it occurred during agricultural season. So the peak harvest got lost by a lot, not only by flash flooding, but also those farmlands that abridged along a river. So this is going to take a little bit of description, but what I've done here is I pretty much have taken the entire Winooski watershed and placed it on a map with individual rainfall reports that we had collected. The stars represent the forecast points along the Winooski, or as well as the Mad River here in blue. And then this chart here on the right is referencing this site right here, which I think I've saved. So let me quickly get into chat here. I've shared it on chat. That link is a link to the NOAA's Atlas return period atlas. And what it does is these sites here, everything in green in this box that I've highlighted, there will be a representative graph, whether it's a graph or a table or chart, that shows you your 5-minute duration for 1 year, your 30-minute duration, or in cases for the bigger heavy rainfall events, what is your 100-year occurrence for a 6-hour, 12-hour, 24, and 2-day. Now, we all hear of this as a return period, and we say it's a 100-year rainfall event. Well, that's kind of misleading. Really, what this data represents is a 100-year rainfall event is actually a 1% chance of occurring at any given year. If we were to have a 200-year rainfall event, that basically represents a 0.5% chance of that rainfall occurring any given year. And I think it's important to look at that rather than the return periods, because we've seen in the Mississippi River Valley that in 1993, they had 200, quote, 500-year events separated by no more than 30 to 60 days. So it's really looking at this, it's more of the percentage of the chance that you're going to have this event occur any given year. So if we go back one slide, what I basically wanted to show you here is with Irene, which was a 12 to 15 to a 12 to 18 hour rainfall event, that these reports you see in here, that the rainfall was largely a 100 to perhaps 500, or better yet, a 0.2% or a 1% chance of occurrence any given rainfall. And you can see by the highlighted red box, that represents basically the whole basin. And the whole basin, for the most part, received 4 to 6 inches of rain. And that is why that starting at Montpelier, going downstream to Waterbury, including Moortown and Essex Junction, every single one of those flood stages received major floods, is because that entire basin witnessed a 0.5 to 0.1% rainfall event. Now, the Long Island hurricane, New England Hurricane 38, this hurricane moved at some 60 to 80 miles an hour forward speed. So when it entered Long Island, it was at 3 o'clock. By the time it exited Vermont, it was at 8 o'clock at night. And this is the only landfalling hurricane that was still a hurricane strength when it crossed the border in the state of Vermont. Of all our tropical systems that we have had, including Irene, the 38 hurricane was the only hurricane that was still, by definition, a hurricane when it crossed into the state of Vermont. You can see the rainfall wasn't anything that great here. 5 inches is in this red. The burgundy color is 7 inches. So you can see the highest rainfalls were largely across central and southern Vermont, largely southern Vermont. Nonetheless, there was still a lot of impacts. Hurricane force winds that did a lot of damage to our maple groves and our apple orchards. Flooding, well, a combination of flooding and tree damage blocked over 2,000 miles of public roads. The storm killed 5 people in the state. The July 23 and the June 1973 flooding, very similar meteorological conditions that caused the flooding. You can see the more outdated pictures here. The far right is from June of 73. And then the more current pictures here are from July of 2023. The White Cottage snack bar in June of 73. I've seen it, but I can't find it again. There's actually a photograph, very similar looking, of what happened in July of 2023 over there in Woodstock. But you can see a lot of the flooding that occurred, the Swiftwater rescue assets, and I really can't enough emphasize the great work that these folks do at our state Swiftwater rescue teams. Prior to Irene, there were only 3 teams that were designated to do this work prior to Irene in 2011. Now there are more than 24 in the state. So a great amount of work has been done by state leaders and the folks at the state fire and safety that have moved these efforts forward. So the July 2023 flooding, again, this red box represents the footprint that saw 4 inches or more of rainfall. And with the July 2023 flooding, it was more of a 1 to 2 day rainfall event. It was not all, there were periods of maybe 12 hours that you saw some heavy rainfall, but it was really more of a 24 to 36 hour rainfall event. So this red box represents where those areas that witnessed over 4 inches of rain, which was most of the area. It was a little bit less as you got towards Danville. Don't have the data here down in the Washington Williamstown area, but it looks like they did all right. But for the most part, most of the basin received it. And you can see, because most of the basin received these heavy rainfalls, every one of our forecast points recorded major flood stage. And again, comparing July 23 to June of 73, you can see the rainfall footprints are pretty similar. The lighter pink being 5 to 6 inches, and the darker pink being 6 or 7 inches greater. And the June of 73 is to the right, July of 23 is to the left, and pretty much a similar outcome. And the weather system that developed and created this event was very similar, that it was basically a wintertime closed low or steering currents, which are a stall type of system, but was in the heart of the summer where you had tropical moisture, and this tropical moisture comes in the form of thunderstorms. So the efficiency of this is maybe 3 or 4 times of what you would see during a winter type of storm. The most recent is the remnants from Tropical Storm Beryl, when that moved across the area. This was definitely a flash flood problem more than it was a river flood problem, but nonetheless, we did still see some river flooding. Flash flooding occurring in Barnet, Plainfield, Peacham, Richmond, Moortown, and other locations, including Lyndonville. This was the flooding from the Passumpsic, which has shut down, unfortunately, the Miss Lyndonville Diner for the rest of the time. And going to Lyndon State, that was my number one place to go to. So I'm very disappointed on the flooding that happened in July of last year. If you look at my square or graphic, as I've done with the others, you can see that the rainfall footprint with Beryl was a little bit more of the northern basin, from the Moortown area through near Montpelier, definitely through Plainfield, and getting up into the Cabot region, whereas we saw 4 to 5, 4 to 6 inches of rainfall. Less rainfall occurred south of Montpelier and south of Barrie, but still 3 inches in here. And then in the Waitsfield, Moortown saw about 5, Waitsfield only saw 3.5. But you can see that just southwest of Berlin, it was 3 inches or a little bit less. The rainfall occurred in a 6 to 12 hour period, but again, much of the heaviest rainfall occurred, or what would affect Montpelier, came from the branches, the eastern branch of the Winooski that comes through Plainfield and Marshfield and stuff. The contribution from the Dog River from our southeast was really not that great. We didn't have any flooding on the Dog, but we did have flash flooding in the Barrie region, just because we saw 3 to 4 inches of rain in a 2 hour period in the urbanized areas of Barrie. So in this situation, Montpelier never saw flood. And along the Winooski, there was no flooding on the Montpelier. It reached very close. The flood stage was 15. It got to 14.5, but there wasn't an issue. Meanwhile, upstream at Middlesex did see major flood from contributions that came from the Mad River, especially what came from around the Moortown area further. Waterbury, because of all that rainfall that came in from the Winooski east of Montpelier, and then the contributions from the Mad River, that forced Waterbury to reach major stage. And of course, all that flows into Essex, and Essex saw some flash flooding. And then just to reminisce of what actually happened, the remnants of Beryl was actually across the eastern Great Lakes. There was another weak area of low pressure in central New York. And in this lower left is the tropical moisture. We're talking in a column of atmosphere, 2 to 2.5 inches of water, which is basically near historical highs. And it just was a result of all these thunderstorms that trained over the same area that's in that oval shape across the black. Rainfall from Beryl last year, you can see again the oval showing largely 3 to 5, 3 to 6 inches of rainfall. Very similar to what happened in May of 2011. And therefore, I'm going to compare 2011 with Beryl. So once again, Beryl is in the right. The May 2011 is on your left. From there, it looks like it's the same footprint, but the footprint was a little bit more further south with the 2011 flooding than what was with um, last year's flooding. So if we take a look at that box that I've shown you again, with the 2011 flooding, you notice that the box represents basically where there was 4 inches or more of rainfall. And you can see 2 of our gauges actually here, the Moortown as well as the Waterbury. Rainfall was still heavy, but largely 2 to 3 inches of rainfall fell there. Montpelier, basically 3 to 5 inches of rain or 4 to 5 inches of rain fell there, as well as in Barrie and along the upper reaches of the Winooski flowing down. So what happened here was, because you had more of a footprint, including down to the south, you did see major flood status at the gauge in Montpelier, and you saw flooding in downtown Montpelier. But Moortown, because there wasn't much rain upstream from Moortown, they never flooded. They reached only action stage. Waterbury was only moderate stage because of the major flooding that came upstream, came from upstream Montpelier down to Waterbury, but the contributions from Middlesex were not as great, or from Moortown weren't as great. And then, of course, further downstream in Essex, you only had moderate flooding because of the lack of contributions from the Mad River. And here's what it looked like on radar and the end result. We had a stalled boundary, delivered multiple heavy rain showers and thunderstorms for about a 12 to 15 hour period. And the end result was some of the flooding. The picture here shows the flash flooding in Cabot. The one in the lower right, I believe, is flash flooding from Cabot. And then this is a picture of Route 302, I believe, in Barrie from the flash flooding. Let's get away from what falls out of the sky and what's happened on the ground. I guess there's a little bit that comes from the sky as well. This is a summary of what happened with the December snowmelt flooding that occurred December 2023. The graphics here in the lower section of the central part of the page pretty much shows a snowpack of 1 to 3 inches from our early December storm. So this was an early season snowmelt. Given the fact that you had a snowstorm around a week to 10 days prior to this event, the snowpack never really got super cold. The snowpack was pretty much ripe and available for melting because it was so close to the actual event that happened on December 17th through December 19th. So when you had temperatures in the 50s and you add 2 to 2.5 inches of rain, your snowpack went from 3 inches in some locations to less than an inch. So with this event, you had 2 to 2.5 inches of rain occurring on top of 1 to 2 inches of snowmelt over a 2-day period. So you didn't have the flash flooding that you witnessed in all the other situations I brought up, but you did have stream flooding and you did have river flooding. As you can see from the hydrographs from the Winooski at Montpelier here, which reached moderate stage, the Winooski at Waterbury, which reached moderate stage, just below major stage, the Winooski at Essex exceeded major stage, and then the Mad River at Moortown just reached major stage as well. Again, no flash flooding, but a lot of field flooding, low road flooding, tributaries, and main stem. And then lastly, for flooding for historical reasons, March of 1992, which was basically, if there was no ice jam, it would have, if there was no ice jam, flooding more than likely would not occur. But we had the series of ice jams, the bigger ice jams being along near Bailey's Bridge, I believe upstream along one of the bridges. Taylor's Bridge had something, and it happened basically where at Cemetery Hill, and that's where the main ice jam was, and everything backed up. And needless to say, you had some major chunks of ice and some backwater that caused flooding in downtown Montpelier during the event. So in summary, for precipitation and what is needed, largely 3 to 4 inches of rainfall is needed, including maybe snowmelt as well, to lead to any onset flooding for many of the subbasins. Antecedent conditions play a significant role. So if you've had 3 to 4 inches of rain, but you've been in a drought or there really hasn't been much rain, then your chances of a flood or severity of flood are much less than if you had wet conditions. The magnitude of flooding is largely dependent on 4 factors: the amount of rainfall, the duration of that rainfall, the aerial coverage, and as I mentioned, the antecedent conditions. And then in terms of the main stem flooding for the Winooski, it really is dependent on how many of the subbasins have been impacted with the heavy rainfall to determine what parts of the main stem will flood. So what I highlighted in this box here is with approximately 5 inches of rainfall, a 5-inch rainfall footprint, depending on the time that occurs, determines your return interval or your percent of occurring. A 5-inch rainfall occurring in a 6-hour period has a 0.2% chance of occurring any given year. A 5-inch rainfall in a 6-hour period has a 0.5% chance of occurring. But a 5-inch rainfall in a 24-hour period has a 2% chance of occurring. So really, the shorter duration of a heavy rainfall is going to give you your greatest issues. All right, it looks like I still have time, John, so I'm going to quickly go into hydrographs. Let me click on this for 2 reasons. One, to show you what comes up when you click on that, but also so I can take the URL and immediately dump it into the chat. Did it take? Nope, it didn't. It took something else instead. So let's try that again. Nope, it didn't do that. So anyways, the URL works, but for some reason I can't just do a simple copy and paste at this time. So maybe I can do it that way. No, I can't. So it's simple enough. And there's many places you can get it. In fact, this is what shows you where you can get it. If you go to our main website, which is weather.gov, it's on the slide in the lower right, you'll see this map. If you click on rivers and lakes, you will get this map that's displayed on the right. What I've highlighted basically is the Montpelier gauge. So if I go next and blow up to that area, here is the gauge at Montpelier. Here is Washington County. What you would get when you click on that green box is you'd get the Winooski at Montpelier. The first half of the graph would be your observed graph. The latter half to your right is the forecast graph, the deterministic forecast for the next 60 to 72 hours. Also on this website, you will get historical data. You will get what floods at various levels of the river at that particular gauge site, what may flood. Again, it's a 3-day deterministic forecast. You can also get recent crests over the past couple of years. You can also get historical crest in here. And your categories of major flooding, moderate flooding, or minor flooding. In addition, what has been there and what will be coming soon is an experimental flood inundation mapping called FIM. Some people have already been trained on FIM. There have already been some public training on FIM. There's going to be more to come from our office, but this is going to be flood inundation mapping. There are going to be 4 different aspects of the flood inundation mapping. The most detailed one will be the one that comes at already existing forecast points like the Montpelier. So what I have here is the Ohio River at Paducah during that flooding that they had about a month ago. The gauge to your right here is again, to the left of that dashed line is your observed observation at the Ohio River at Paducah. So it's showing it's in moderate category at 46 feet. This to the right of the dashed line is the deterministic forecast from the River Forecast Center. And then these 2 graphics to the left, these 2 maps, the map on your left is what the Ohio River would normally look like if it's not in flood. This is an inundation map of what was going on at that particular time of the flood. And you can see, especially to the northeast of the main river banks of Paducah, there was a lot of flooding going on. Again, the flood inundation mapping is coming soon. We should have it for our main stem rivers and maybe some other rivers. Our hope is by the beginning of fiscal year 2026. Of course, with recent changes and budgetary changes at the federal level, I'm not saying it's going to be delayed, but nothing surprises me when it comes to federal spending and federal deadlines. But right now, it's looking at fall of did I say beginning fiscal year 2026 or the fall of 2025? So the fall of this year. Meanwhile, what we do have on some of our gauges is also what you can get is called the probabilistic solutions on the ensemble graphics. If I go back to, no, I don't think it, oh, yeah, I would. I'll show you later, but if you go to rivers and lakes, you know what, I'm going to do that now. I'm calling it audible. Sorry, folks. So if I go to our website, click on, if you put your cursor over rivers and lakes, you get current past stream flows, ensemble river guidance. This is our observations and our river forecast map that I just showed you earlier. Let me click on it again. There you go. But if you go to this ensemble river guidance, it is going to give you, you know what, I'm going to just do everything from here, honestly. Maybe it makes it just to show you how it is. It is going to be color coded based on if during any time in the 7 to 10 day window, if the river is going to be at action stage, which is the yellow, minor stage, which is the orange, moderate stage, which is red, or the purple, which is major stage. So it has here within the next 7 to 10 days that the gauge at Center Rutland may reach action stage. You can see up here in Montpelier, it doesn't look like it's going to occur. Come on. But you can see that there is some hydrographs that's showing some different ranges of potential solutions based on the rainfall we're going to see this weekend. Let me get back to my chart here. No, not from the beginning. Scoop. And there. So here's a look at Rutland. The ensemble is suggesting there's a 30% chance that will reach the action stage. So if I looked at the hydrograph for Otter Creek, you can see that the Otter Creek right now is approximately 5.2 feet, and it is scheduled to go down through the 9th at 8 a.m. The 9th would be Friday morning. But then we get some rain Friday into Saturday, and then the solutions are all across the board. The blue line represents the median of these solutions. The blue colored area represents the 25 to 75% likelihood that this will be a solution. And it is based off of the 25 to 75% likelihood of the forecasted rainfall. So if we're forecasting deterministically an inch and a half for Rutland, the 25 to 75% is likely ranging from 3/4 of an inch of rain in Rutland to maybe 2 inches of rain. And this ensemble or set of ensembles basically just shows us what is the possibility. So when you get future in time, when you get into the first 3 days of the forecast, your deterministic should be pretty good. But I still like using this ensemble graphic because the deterministic will still be based on, say, you're forecasting 2 to 3 inches of rain. Well, what happens if the storm overachieves and you get 4 inches of rain? The deterministic is not going to give you a solution for 4 inches of rain because it only put in for 2 to 3 inches of rain. This will give you a first guess of what the other solutions could be like if that occurs. But I am going to put a big caveat. Use this with extreme caution. There are multiple simulations. They're only run twice a day with multiple solutions. These models that run this stuff are Very synoptic, very large scale models. They don't take the finer resolution that's in place. There is limited quality control on the data that's going into these models. And again, they are available up to 10 days. So it is good to kind of know, is there a possibility of flooding? But say if that minor flooding for Center Rutland in that green, pretend that was major flooding for Montpelier. I wouldn't want people to freak out about that. If they see something that's going to suggest minor, moderate, or major flooding in a 7 to 10 day window, or even a 3 to 5 day window on this graph, I would say the first thing you should do is reach out to us and say, is that even a probability? What is the likelihood of something like that occurring? Instead of making plans just solely on that, I would definitely reach out to us. And if we don't have the 100% answer, we would reach out to the hydrologists at the Northeast River Forecast Center to get their take on what's going on. Lastly, we're talking about a resilience group. So we're talking about mitigation and preparations and getting ready for any future flooding. So there's a program within the National Weather Service, and with FEMA is slightly involved as well, called Storm Ready. It's about communities getting themselves building for the next and preparing for the next significant weather event. I would go to that website that's there, take a look, see if you want to be involved in Storm Ready. Basically what it is for the local communities is making sure that you have 24/7 communications, and then any local emergency action plans have some sort of weather annex for anything that could occur. So you know what to happen. So you're not like all of a sudden an event happens and you've got no plan. You have something, whether it's online, whether it's in a 3-ring binder, and it gives you actions of what you need to do. So just wanted to pass that along to all of you as well. And with that, I've taken up more of your time than really wanted to. So somebody has asked me, or John asked me, about future rainfall and future climate. In today's environment, and I think you know what I mean, I am going to limit about speaking about the future in climate. These are links and resources to national climate assessments that have been done, which will share some of the information. But the one thing, if the question is asked, has there been an increased frequency of heavy rainfall events? I'll answer that, yes. So with that, I'm opening it up for questions, John.
I guess a follow-up question to that is, with that increase in frequency, those percentages you share about sort of a 2% likelihood, 1% likelihood, do those reflect the current environment, let's say, or are those sort of historic where they need updating? How much trust can we put in those frequencies, those percentages?
John, I'm glad you mentioned that, because it is somewhat historic. They try to update these things every 10 years or so. There is a new update expected for 2026. And let me share my screen again. Find that here. And if we go back to that chart, oops. I know, there it is. In bold is a standard point. There's actually ranges within, in parentheses underneath this. So I think that's where it's taken in some confidence. It's a 90% confidence level. So with there being a range, they pretty much they can fall within these values. So they stay somewhat current. But there is a new atlas that is coming out, hopefully in 2026. Although NOAA's funding got chopped severely with or is getting proposed chopped severely with this upcoming budget, and they're trying to keep the field offices like National Weather Service forecast offices that issue warnings. They're trying to put their money more in warnings than they are with some of the research. So I can see maybe that the Atlas 15 is delayed a little bit, but we'll see. But there is a plan to update that, but I don't think it's too far off right now. But you're right. With the more frequency of these events, there's likely that we will start seeing these values change.
There's a question about river gauges, and I think it's a twofold question. One is, would more river gauges be useful for you to some degree from a forecasting standpoint, but also for communities to have a better sense, right? Particularly, it feels like those river gauges with the forecasting component can give a little more local precision around what to expect. So just, I guess, curious to get your take on that.
Yeah, more data is better. I mean, there's no doubt. More data is better. The funding of how these river gauges are in the state of Vermont, actually it's across the country, is U.S. Geological Service they install and they maintain these gauges. And the gauging program started way back. I honestly, I don't know. I want to say 50s, 60s, before that, actually. And it's always been maintained, and it's always been, or at least more recently, it's a 50% federal, 50% state or local contribution to maintain these gains. The first time, it's not just a first-time issuance and get the gauge in there. It's the maintenance. It's developing a rating curve for potential future forecasting at that particular site. So they're not cheap. We're looking at, if you wanted a full rating curve, we're looking at, I think, somewhere in the $15,000 to $30,000 a year maintenance thing. Now, in terms of having some sort of a gauge that measures the level of the river and at a certain threshold has some sort of audible alarm. I'm not saying a siren for the district, but does some sort of, whether it's activating a reverse 911 or notifying your public safety building or your town hall of a certain level has been reached, and it's a series of steps that you need to take to let your constituents know. That I don't know what the costs are. That's not pretty much. That is not something done through USGS, as far as I know. I believe that would be just something local municipalities can look into, and frankly, in places like Plainfield and East Montpelier, or places that there's just no gauges and it's more of a flashy nature, that would be the type of gauge that should be considered if people feel that the risk versus reward is the amount of money we spend on maintaining something like that. Is that worth, what the actual flood or another flood would come? So that's something for local communities to look into. But that certainly, I would think, and I don't know the technology that well, but I would think that is going to be easier to obtain. But I don't know if, and in terms of federal funding on something like that, there's always grant money around. There's all sorts of federal grant money, or there used to be. What's available for something like that, whether it's through FEMA, whether it's through, I don't know, it could be Small Business Administration, as far as all I know, because of agricultural crops or whatever, I have no idea. But for those that are in quick sub-basins, that would be where I would try, because the other problem is if you do something like, if you try to get the current gauges or forecast points like we currently have right now, say there's abundance of money, it's still limited to USGS. If the USGS is not, if their budget is not increased, then they're not going to be able to provide their 50%. Not to mention, they're not going to be able to hire the staff in order to maintain those gauges. So it's complicated. I wish we had all the money in the world to do all these things, but unfortunately, it's very complicated when you start getting into what the state can do, what the federal can do, and when you're changing administrations every 4 years, it makes it even harder.
Yeah. Mark asked a question. Some of the gauges seem to use the level above sea level versus sort of the river level. why the difference, or yeah?
That one would have to be passed on to John Goff, who's our service hydrologist. Most of them are referred to is based on a datum in the river or whatever. And I honestly don't know. I have some idea, but I'm afraid I will explain it wrong. So instead of me doing it wrong, I'd rather just have talk to John Goff here at the office to get a little bit more better feel on that.
That's great. I don't know if you see this question, and this might not be your bailiwick. Pat thinks maybe it's for next week, but Mike Dacey's got a pretty specific question around the difference between HEFS/GEFS/NAEFS models in terms of. And Mike works in Waterbury, right? And similar for us in Montpelier, a lot of what we're doing is trying to give the public enough information so they act when they need to act, but also they don't panic when they don't need to act, right? We are looking for sort of both the best data and the best way to communicate that data to really help inform the public. And I think that's part of what Mike's getting at there.
Yeah. Mike, on that, so here's that ensemble page that I referenced you to, and we'll just take Waterbury. I click on Waterbury, and right, you're looking at different data. The default in this one happens to be the NAIFS. There's the JEFs and there's the HEFs. Those are three different models, and basically, it's just what other weather models are being used into these simulations. So the NAIFS is a North American model. The JEFs, I think, is strictly just like a U.S. and Canadian opponent. And the HEFs is supposed to be a finer resolution model. But I'll tell you what, the HEFs has not proven itself. It doesn't work that well. So just leave the HEFs alone. Just don't even look at the HEFs at this point until we find it better. We found the JEFs and the NAIFs are pretty similar, but there could be an outlier. So if you go to this link here for Waterbury, the first link you get is the river level probabilities. And how are they determined? This one's still a river level probability, but you see the individual models, and you see this one individual model here has Waterbury going to 2 feet over moderate stage, where if you look at all these other individual models, and if you look at all the shading, which is combined of these, none of them some may get it to action stage. So what's the difference? Oh, it's not on this one. Darn. Some officers don't have it. Let me see about Montpelier. See if I can get through Montpelier.
We're not looking at your screen, just so you know. I don't know if you think your screen is shared.
Oh, my apologies. Let's get back to it.
Well, and I do. We're kicking right up on 1 o'clock.
Yeah. Okay, so let me show you real quick. So basically, let me get one more. Let's get Montpelier, see if they have it in there. So it's defaulted to NAIFS. Here's all the different rainfall potentials, and you can see in this blue, 25 to 75% is the most likely, but you do have some outliers as much as 4 inches. And that's why sometimes you can get, even though your ensemble has us near 13 feet, or 11 feet at the worst case right now, there are some individual river levels that are forecasting maybe as much as minor flood stage. And I think that's based off of 1 or 2 solutions. So the problems could be the rainfall amount in there is bad, or the model simulation in terms of how it channels the rain from point A to point B, the location itself could be bad. So that's where, if you look at this stuff, use the NAIFS and the JEFs, don't use the HEFS, the HEFs, don't use that, and always contact us first, because you will maybe get a spurious outlier, which we call this one an outlier, and we don't want you to be making decisions based on an outlier and cause sheer panic. So we always suggest that you reach out to us to put some to put some emphasis on what's happening on those observations.
Scott, I want to offer you a real deep thank you for being willing to do this, for putting this presentation together for us. I will speak for the group and say it was really informative. We've recorded it because I think there are going to be a lot of people across the basin who are interested in this. I will also just make a note that what I heard you say is when we are in a moment of trying to analyze data and make decisions, what I heard you say is reach out to you and to the National Weather Service office up in Burlington when we're at that point of trying to make some decisions. And so I think that's I just
absolutely, John. VEM does that. City of Montpelier and Waterbury has reached out to us numerous times. And of course, when we're talking about flood, we're talking about potential needing to evacuate people. So Mike Cannon and the Swift Water team of the state reaches out to us all the time. So certainly you need to make a decision, or you want to analyze. You don't need to make a decision yet, but it's 4 days out and you're seeing some of these graphics that alarm you. By all means, reach out. That's exactly what we're here for.
Great. Well, thanks again, Scott. Thanks everybody for coming in on this. And for many of you, we will see you on May 14th at the Crossett Brook Middle School. So thanks so much, everybody.
Thank you.